Hello, welcome to GTech Techno Solution Private Limited. We are going to discuss about stress and strain. Our first question is define stress. Stress is nothing but any arbitrary loading is given to a body and it undergoes deformation. Consequently, some amount of the internal force will be set up in the body to resist the deformation that is produced by the external cause. So the magnitude of the internal resisting force per unit area is defined as stress. The unit of stress is sigma and it is Newton by millimeter square. So this is all about stress. Moving on to our next question. Define strain. When a solid bar is subjected to an axial load, it undergoes deformation both in longitudinal and transverse directions. In the longitudinal direction, it can be defined as the fractional change in length. Strain is a dimensionless quantity and it is denoted by the symbol epsilon. Moving on to our next question, we have define Hooke's law. Hooke states that when a material is loaded within the elastic limit, the stress is linearly proportional to the strain that produces it. Stress is equal to E of strain, where E is nothing but your Young's modulus and it has its unit to be Newton by millimeter square. E is also known as elastic constant. So this is your Hooke's law. Our next question is, what do you mean by bulk modulus? The ratio of change in pressure to the fractional change in volume, that is your volumetric strain, is called as bulk modulus of a material. It is denoted by the symbol K. So your bulk modulus is the ratio of change in your pressure to the fractional change in volume. Our next question is, what do you mean by the term necking? When a material is being loaded to its yield point, the specimen begins to neck, that is, the cross-sectional area of the material starts decreasing, if you can notice over here. So due to plastic flow. Therefore, necking can be defined as the mode of ductile flow of material in tension. Necking usually occurs where the surface imperfections are predominant. So that is what necking is all about. Our next question is, what is meant by principal plane? Principal plane is a plane in which the stress vector will be wholly normal and there will not be any tangential or shear stress in that particular plane. If a plane is like that, then it is called as principal plane. Your stress vector will be wholly normal and there won't be any tangential shear stress. So that is your principal plane. Moving on to our next question, we have, what is principal stress? The normal stress which is acting on the principal plane is called as your principal stress. Our next question is, what do you mean by state of stress? The totality of all stress vectors acting on every possible plane passing through a point is defined to be the state of stress at a point. So that is what about state of stress at the particular point in a plane. Our next question is, what do you mean by octahedral plane? A plane that is equally inclined to all the three principal axes. Then the plane is called as octahedral plane. So if you see, you have three principal axes that is going through your octahedral plane. Also, octahedral plane is free from normal stress. Our next question is, list out any 5 important theories of failure. The following are the theories of failure. Maximum principal stress theory or Ranke's theory, maximum shear stress theory or Tresca yield theory, maximum elastic strain theory or Saint-Venant's theory, maximum elastic energy theory, and the final one is energy of distortion theory. So these are the 5 important theories of failure. Our next question is, state the theory of maximum elastic strain energy. According to this theory, the failure occurs at a point of the body when the maximum strain at that point exceeds the value of maximum strain in a uniaxial test of the material at the yield point. So if you see, the failure occurs at the point where the maximum strain exceeds the value of the maximum strain that can experience. So this is your maximum elastic strain energy. Our next question is, state the theory of maximum elastic energy. According to this theory, the failure at any point in a body subject to the state of stress begins only when the energy per unit volume absorbed at the point is equal to the energy absorbed per unit volume of the material when subjected to the elastic limit under a uniaxial state of stress. Moving on, our next question is, state the energy of distortion theory. According to this theory, the energy absorbed during the distortion of an element is responsible for the failure and not the total energy absorbed is responsible. You have to take a note that the energy of distortion can be obtained by subtracting the energy of volumetric expansion from your total energy. Our next question is, What is a beam? A bar subjected to forces and couples that lie in a plane containing its longitudinal axis is called as a beam. So the forces will act perpendicular to the longitudinal axis of the bar. So this is what is a beam. What is meant by transverse loading of beam? If the load is acting perpendicular to the longitudinal axis of the beam, then it is called as transverse loading of the beam. So this is what is transverse loading of the beam, where your load is acting perpendicular to the longitudinal axis of the beam. Moving on to our next question, we have, what are the types of loads? So these are the types of loads. If you see, point load with zero inclination, point load with some inclination to the transverse axis, uniformly distributed load, that is UDL, varying load, and then followed by the moment. So these are the types of loads. Our next question is, define bending moment. Bending moments are internal moments developed in the material of a beam to balance the tendency for external forces to cause rotation of any part of the beam. So this is what is known as bending moment. Our next question is, define a column. Column is a vertical, long and slender member which is subjected to only compressive load. Every discrete cross-section of the column will be in a state of axial compression. So that is what a column is all about. What are the failure modes of columns? The answer is, columns are classified into long columns and short columns based on the slenderness ratio. In general, long columns always fails by buckling and short columns always fails by crushing of the materials in the column. So these are the failure modes of columns. Our next question is, what is power? Power can be defined as the rate of transferring energy. It is calculated as P is equal to T multiplied by N, where P is nothing but your power and T is your torque and N is the rotational speed. So that gives the value of your power. P is equal to T multiplied by N. Moving on to our next question. What do you mean by torsion? Torsion refers to the loading of a circular or non-circular member that tends to cause it to rotate or twist. So the loading will cause rotate or twist. Such a load is called as torque. There are three types of torsion moment. The three types are as follows: torsional moment, rotational moment and twisting moment, or simply couple. So these are the three types of torsion moment. Our next question is, what is torsional stiffness? The measure of torsional stiffness is the angle of twist of one part of the shaft relative to another part. When a certain torque is applied, it produces the angle of twist. So this is known as your torsional stiffness. Our next question is, state any two major functions of a spring. Some of the major functions of the spring are as follows. It is used to absorb the shock energy, and it is used to measure forces in spring balance and engine indicators. So this gives the major functions of a spring. Our next question is, name the various methods of determining slope and deflection of beams. The various methods include double integration method, Macaulay's method, moment area method, and conjugate beam method. So these are the various methods of determining your slope and deflection of a beam. Our next question is, define the term slope. Slope is nothing but it is defined as the rotation of the beam axis from its original position. So the amount of rotation that a beam does from its original position is known as the slope of a beam. Our next question is, what is meant by a conjugate beam? Conjugate beam is a fictitious beam which has the same length as that of the real beam, but supported in such a manner that when it is loaded with M, flexural rigidity, by EI. The diagram of the real beam is given over here. The shear and the bending moment at a section in the conjugate beam will give the slope and the deflection at the corresponding section of the real beam. So this is what is meant by a conjugate beam. Our next question is, what is deflection? The answer is, displacement of a particular point located in longitudinal axis of the beam in vertical direction is called as your deflection. The deflection may be either upward or downward depending upon the direction of the load which it is acting upon. So, displacement of a particular point located in the longitudinal axis of the beam is your deflection, and it can be upward or downward depending upon the direction of the load. Our next question is, define fatigue. Fatigue is nothing but a phenomenon loading to fracture under repeated or fluctuating cyclic stresses below the tensile strength of the material is called as fatigue. We have to note that fatigue fractures are progressive, starting as minute crack developing under the action of fracturing stresses. So here you will be able to see that the crack is occurring, which leads to fatigue as it progresses. Our next question is, what is fatigue life? The number of cycles of stress that can be sustained prior to the failure of a specified nature of a stated stress condition is called as the fatigue life. So that gives a fatigue life. The cycles of stress that can be sustained prior to failure. Our next question is, what is overstressing? The damage to fatigue properties of a material by cycling for a time at a stress above the fatigue limit is called as overstressing. So the damage that occurs to the fatigue itself by cycling for a time leads to overstressing. Our next question is, what is cycle ratio? The ratio of the number of cycles n of stress applied to the specimen or the structure to the number of cycles to failure, that is capital N, at the strain stress is denoted as small n divided by your capital N, that is the number of cycles divided by the number of cycles to failure, and it is known as your cycle ratio. So this is what is meant by cycle ratio. Our next question is, what do you mean by pressure vessel? Pressure vessel is usually a spherical or cylindrical container intended for the storage of liquids and gases under high internal pressure. So this gives a pressure vessel. Our next question is, define hoop stress. The stress that is acting in the circumference of the cylinder wall, or the stress induced perpendicular to the axis of the cylinder, is known as hoop stress. Our next question is, what are the general shapes of pressure vessel in practice? So the general shapes of pressure vessel in practice are cylindrical and spherical. Our next question is, define longitudinal stress. The stress that is acting along the length of the cylinder is called as longitudinal stress. Thank you so much for joining GTech on stresses and strains. Hope you would have got an idea about the interview questions based on stress and strain.